So this is another example of how to solve a word problem. So once again, we're going to use GRASS, which is given, required, analysis, solution, and statement. So the question is, an equilateral triangle has sides of length s. Express the height as a function of s. So given in this question, we know that the length of all the sides of the triangle are going to be s because it's an equilateral triangle. So when it says equilateral, it means that all sides are equal. So that's really all that we're given in the question. So we can move on to what we're required to find. And what we're required to find is h as a function of s, because it's expressed the height as a function of s. It's going to be h of s because s is going to be your variable. So for the analysis step, I'm going to attempt to draw an equilateral triangle. So although it may not look like an equilateral triangle because I just drew it, all these sides are actually equal, so they're all s. And the height here is going to be h. So one thing that we can also see in an equilateral triangle is that it's actually two right angle triangles. So this is actually can be split up into two right angle triangles. And in the middle, these both are height. And since we're splitting this base into two, the length for the bottom here of this right angle triangle is going to be s over 2. So now that we see that we can just break that equilateral triangle in two, we can just use one of the sides. So a formula we're going to have to use is Pythagorean Theorem. So Pythagorean Theorem says that the hypotenuse squared is equal to the one side squared plus the other side squared. So in ABC, if C was our hypotenuse, it'd be C squared is equal to A squared plus B squared. And this side would be A and this side would be B. So our values for C, A, and B, C is equal to S, A is equal to h, and b is equal to s over 2. So if we sub those in, we have s squared is equal to h squared plus s over 2 squared. So for the solution, what we have to do is we have to isolate for h in order to get a function h of s. So the first thing I'm going to do is actually square this term. So it's going to be s squared is equal to h squared plus s squared over 4. So now that we have that, we can start to isolate for h. So in order to get rid of this s squared over 4 on the right side, we have to minus s squared over 4. So those two will cancel. And then what we do to the right side, we have to do to the left side. So we're going to have s squared minus s squared over 4 is equal to h squared. So now just to simplify the left side a little bit, we have s squared minus s squared over 4. And if we factor out the s squared, we'll have s squared 1 minus 1/4. And 1 minus 1/4 is actually 3/4. So it'll be s squared times 3/4. So it'll actually be 3s squared over 4. So now this turns into 3s squared over 4 is equal to h squared. So now what we can do is we can take the square root of the right side to get rid of this squared here. And then we can square root this side because what we do to the right side, we have to do to the left side. So it's going to be h is equal to the square root of 3s squared over 4. So now if we square root each individual term, we'll get h is equal to the square root of 3 times the square root of s squared over the square root of 4. And now to simplify that even more, we're going to get h is equal to the square root of 3 we can't simplify, it's just going to be the square root of 3. The square root of s squared, the squared and the square root are going to cancel, so you just be left with s. And then the square root of 4 is 2, so we can divide by 2. So now you have to do your therefore statement. So it's going to be therefore h as a function of s is h of s is equal to the square root of 3s over 2. So that is how you solve this word problem.